Okay students, so in the previous class we have seen the definition of probability, the conditional probability and Bayes theorem, and also we have discussed some formulas on that. Now let us solve some problems on this. Now see the problem here, if the probability that a communication system will have high fidelity is 0.81 and the probability that it will have high fidelity and selectivity is 0.18, then what is the probability that a system with high fidelity will also have high selectivity? Now whenever you just go through the problem, you just identify what are the events covered here. So if you come to the solution here, we have a system with high fidelity and high selectivity. So let the F represents the high fidelity here and S represents the high selectivity. Then clearly it is given that a communication system will have high fidelity is 0.81, that means probability of F is 0.81 and the probability that it will have high fidelity and selectivity is 0.18, means it has both the fidelity and selectivity. So probability of F intersection S is given as 0.18. Now what we have to find is that a system with high fidelity will also have high selectivity. It is clearly mentioned that it has high fidelity, but also it should have high selectivity, means we have to find the conditional probability. So we have to find probability of S given F. So as I mentioned in the earlier class also that whatever is there in the denominator is a completed event and whatever is there in the numerator is about to happen here. So a system will have high fidelity, it is already there, and we have to find with high selectivity also. So if you go through the formula, it is probability of S intersection F by probability of F. So what is probability of S intersection F here? 0.18 by probability of F is here 0.81. So must and should you have to represent the answer in terms of decimal only, whatever the probability problems are there. So if you calculate this 0.18 by 0.81, it is 0.222. So a communication system will have high fidelity, will also have high selectivity is 0.222. That is the solution of this answer. So this type of problems will be there for conditional probability. Now coming to the second problem, here some data is given to you and we have to find the probabilities of that. So if probability of A is 1 by 3 and probability of B is 1 by 4 and probability of A union B is 1 by 2, then we have to determine the value of probability of B given A and probability of A given B complement. But we know the formula of probability of B given A, that it is probability of A intersection B by probability of B. So here we have probability of A, probability of B and probability of A union B. So from that we have to find the probability of A intersection B. So probability of A intersection B is given by the formula. We know the formula that probability of A union B is P of A plus P of B minus P of A intersection B. Now here we have to find the P of A intersection B. So it is P of A plus P of B minus P of A union B. So P of A is 1 by 3, P of B is 1 by 4 minus it is 1 by 2. So here the value is 1 by 3 plus 1 by 4 minus 1 by 2, it is 0.0833. So this is the value of probability of A intersection B. Then the first bit we have to find is probability of B given A. So probability of B given A is given by the formula probability of A intersection B by P of A. So 0.0833 by P of A is 1 by 3. So this is nothing but 0.2499. Now the second bit you have to find is probability of A given B complement. So probability of A given B complement is given by the formula probability of A intersection B complement by probability of B complement. So here we have to find both the probability of A intersection B complement and also probability of B complement. So probability of B complement is nothing but 1 minus probability of B. So 1 minus 1 by 4 is how much? 1 by 4 means 0.25. So 1 minus of that is 0.75. 0.75. Now, probability of A intersection B complement is given by the formula probability of A minus probability of A intersection B. So, what is probability of A? 1 by 3 minus probability of A intersection B is 0.0833. So, here the answer is 0.25. Now, substitute in the formula of probability of A given B complement, that is 0.25 by probability of B complement is 0.75. So, 0.25 by 0.75 is 0.33, right. So, using the De Morgan's law, we have to find this statement here, okay. So, if you see the problem on Bayes' theorem, in a certain college 25% of boys and 10% of girls are studying mathematics, right. So, in a class they are discussing about the subject mathematics here. So, the girls constitute 60% of student body, and what is the probability that mathematics is being studied, and the second one is if a student is selected at random, the probability that the mathematics is studying by a girl we have to find here. So, from the given data, probability of girls is 60% means 0.6, and probability of boys will be ultimately out of 100%, 60% of girls means the remaining is 40%, that is 0.4 is the probability of boys. Then girls in a certain college 25% of boys are studying mathematics. So, that means here probability of M given B. So, boys are 40% and they are studying mathematics. So, it is 25% means 0.25, and 10% of girls are studying mathematics. So, probability of M given G is 0.1. Now, we have to find the probability that the mathematics is being studied. So, we have to find probability of M. Here M represents mathematics subject. So, this is probability of G into probability of M given G plus probability of B into probability of M given B. So, probability of G is here 0.6 into probability of M given G is 0.1 plus probability of B is 0.4 into probability of M given B is 0.25. Now, simplify this using calci. So, 0.6 into 0.1 plus 0.4 into 0.25. So, it is 0.16 means the probability that the subject mathematics is being studied by both girls and boys is 0.16. Now, the second bit you have to find is that if a student is selected at random is found to be studying mathematics is a girl only, not for boys, right. So, that means we have to find probability of G given M means they are studying mathematics but it is a girl. So, probability of G into probability of M given G by summation of I equal to 1 to 2, right. So, the Bayes theorem, right, actually it is probability of EI into probability of A given EI, but here we have mentioned in terms of G and M. So, we have to use probability of G into probability of M given G plus probability of B into probability of M given B. So, that is probability of G into probability of M given G is 0.6 into 0.1 by this is nothing but your total probability P of M, which is nothing but 0.16. So, 0.6 into 0.1 by 0.16 is 0.375. So, the probability that a girl studying mathematics is 0.375.